Okay, we're on 32. What do we do? We talked about the substitution that we're going to be dealing with. So the bottom line is understanding substitution. It really revolves around this over here, and we did derive this, all right? So what are we looking for? Well, I'm going to write it down. I'm going to write down cosine of x. The substitution we're going to use is 1 minus t squared over 1 plus t squared. So if I see a cosine of x, I'm going to write that down. What else am I going to write down? If I see a sine, I'm going to write this down. Well, also the understanding the dx should be written as 2 1 plus t squared dt. And again, remember we said this is a pretty sneaky substitution that we're making over here. I don't think it's obvious in any respect, by the way. And certainly when I say that, this guy here, he was a bright guy. I mean, just even the fact that he was able to prove the intermediate value theorem really cut his name in stone. If you do remember studying the intermediate value theorem, they use W for that number they're looking for, the intermediate value for a continuous function. But anyway, we're not doing that. We're doing this one over here. And it's easy to forget this, by the way. So let's write this down then. We're going to make this substitution, all right? So someone says, what is it going to look like? Well, I'm going to put a star here because I'm making this really tricky substitution. What do you get? 1. You're going to get 2 plus, well, cosine is going to be 1 minus t squared over 1 plus t squared. Times, well, dx is 2, and then what do you get? You get 1 plus t squared dt. All right, what am I going to do now? I'm going to get my eraser out. And again, this stuff is written down for a reason. We certainly want you to look at it and consult it when necessary. So I'm going to, continue, go forward. I'll put my little star here. We'll look at the key later. I definitely get 2 on top. I definitely get a dt here, all right? So let's multiply the bottom out. What do you get? You're going to get 2 plus 2t squared plus 1 minus t squared. All right, I'm going to keep simplifying this thing as much as I possibly can. And again, the belief is it's going to get easier. So what are you going to get? You can get 3. 2 plus 1 is 3. 2t squared minus t squared is going to be plus t squared. All right, I definitely recognize that, guys, and I want to go through that with you, and then we'll talk about how we're going to do it. All right, what I'm going to do here is I'm going to factor out a 2 on top, and I'm going to factor out a 3 in the bottom. And what do you get? You're going to get 1 plus t over root 3 squared dt. All right? Now, what I'm going to do is just, maybe as a crutch, but I'm going to write this down over here, that u is equal to t over root 3. That means du is going to be 1 over root 3 dt. I'm going to put the root 3 here. All right? So what I'm going to do is I'm going to write that down for you. And this is my second substitution, by the way. So what do you get there? You get 1 plus u squared now. And what's dt? It's root 3 du. So put the du here, the root 3 here. Let's do it. What do you get over there? I think I can enter it now. You're going to get 2 over root 3 times the arc tangent of u. What's u? It's t over root 3. Plus, I've already moved my 1 back, so it's only going to be 1 star now. All right? By the way, you definitely removed the integration symbol, which is really, really good news, by the way. And then the question becomes is, what are you going to put down now? And you may not remember what you just did, but we made a substitution. Right? We definitely made a substitution. And then the question is, what do you do about that? I guess I got to do something, right? So we'll go back and look. Oh, look at this. It's right here. I'll write that down. Get my eraser out. So this is going to be 2 root 3 arc tangent 1 over root 3, and t is going to be the tangent of x over 2 plus c. All right? And then I'm going to say, you can call it quits if you like. Not a bad thing to do, by the way. You definitely found the antiderivative. However, there's going to be some things you may want to be able to retain from your prior courses. But if not, you know what? Don't worry about it. You know, a lot of things you can't remember. You have to look them up. That's fine. And you're looking at notes, you might know how they got that. But I'm going to write down, there's another identity I could use. And then we'll look at the key, by the way. 2 over root 3, arctangent, 1 over root 3. And the half-angle formula for the tangent function turns out to be pretty nice, by the way. And there's 2 different forms of it. I do like this form over the other one, though, sine x. By the way, the forms are written over here, over 1 plus cosine x. Now, granted, I can't say it made the problem any better. It really hasn't. But I want to look at the key. I want to see if I got it. 2 over root 3, arctangent, 1 over root 3, the tangent of half an angle plus c. Also wrote this one down for you. 1 over root 3 sine 1 plus cosine. You get the idea. All right. Now, granted, we also talk about using software to do it. And yeah, it's nice to have some kind of way to check yourselves by certainly looking at answer keys. One way to do it, but also, you know, how do machines handle these things, and how do they do it so much quicker than we do? It's kind of almost frightening, by the way. But anyway, thank you for your attention. We're finished.